Okay, now we'll hear some scientific thoughts by Wesley Traub.
Well, so the good thing is that we will finish early so you can all relax. I'm not going to spend a lot of time here. I just wanted to comment that I think it's very appropriate that at this particular kind of meeting that the societal and cultural aspects were highlighted so much. It's one of the things about searching for extrasolar planets that excites me so much that it's not necessarily that I'm a fan of the common man, but I do like the idea that everybody that you talk to out in the rest of the world can relate to this topic, and it is not some esoteric, spectroscopic, black hole, whatever, kind of thing that we normally do. So I especially enjoy that aspect of extrasolar planet work and search for extrasolar intelligence. So let me move on here. So my comments on the science that I've heard during the last 2 days are basically on 2 slides in the front here, and then I have 2 or 3 after that. And it's not so much science as it is just the technology, which I think is interesting. And my understanding of SETI at this point is that it is basically this radio survey, which now I understand covers a very wide band region that you can do. You cannot just search a very narrow, predetermined area. And being able to look at a broad spectrum and do it continuously on large parts of the sky is, well, I say here it sounds wise. I mean, it sounds like the right thing to do. It's very analogous to the idea of LSST, this idea of searching the whole sky and taking pictures of it in different color bands and just doing it over and over and over again as a scientific project. It seems to me there must be something a lot that comes out of that, not just searching for artificial signals, but a lot of science in general. And I assume that the unexpected philosophy is at the heart of doing something like that. And then I like the idea also of the optical survey, because that covers part of the rest of the band, and you don't have to be a radio chauvinist at this point. And the fact that you could have visible or near infrared both have interesting properties. And for example, just from my point of view, this could, the laser, since as Paul Horowitz pointed out, you can make a laser much brighter than the sun for short periods of the time without too much technology. It could be used as a beacon and say, hey, here I am. And now you can go look at my radio frequencies and try and get the rest of the information. I just thought this whole thing went together very nicely. So that was my take on the science so far. Now, the part that I'm involved in, I would call SETU, or the search for extraterrestrial unintelligence, or search for extraterrestrial mere signs of life. We're not doing anything nearly as dramatic as searching for intelligence. In fact, what I always tell people is that if you look at the history of the Earth, and if you just drop yourself down at a random time in the history of the Earth, and you can detect signs, or what I call signs of life on the Earth, in terms of the effluent gases that come out from these, whatever it is that's alive on the surface, you're basically searching for green slime. And that is not, that inspiring to some people. It's not nearly the same as searching for radio signals, but, it's what we can do. And there's a pretty good chance that there's more of those planets than there are of the kind that SETI is looking for. So there is some sort of chance that we might actually, in spite of all of my unhappiness about the decadal survey and the progress and how fast I'm getting old, there is some chance that we might actually accomplish this in some reasonable period of time. So it's a good thing. And I think that somehow, I've never really thought about it too much before this, but before this meeting, but somehow we should manage to figure out how to make these efforts go forward together. It's not just that we're both the impoverished twins of searching for extrasolar planets, but there must be something that we can do to help each other, and I haven't really completely thought about it yet. But just a few comments about searching for this green slime. What we're doing is, unfortunately, necessarily in space, because the atmosphere is just such a distorting element. and that makes it expensive, and that's an unfortunate thing. Just as a couple comments, it's probably going to be an optical situation. It might possibly be an infrared. And the partial good news is that this could happen sometime in the decade after this one, the 2020s, at least given the bones that were thrown to us by the decadal survey in terms of saying, well, maybe this would be an okay thing to do in the next decade, but certainly not ours right now. And what we would get from this would be images of planetary systems, not images of planets. I realize that I wrote that down incorrectly. It's not like a picture of the planet so you could see continents. It's just a spot of light. But it would give you images of where the planets are in a solar system from Earth size, which is pretty small, and up to bigger things. And we think that we could do things which would image areas of solar systems that range from the closeness of the star of about a habitable zone for a solar type star out to Jupiter and beyond. So that's a big chunk of searching. And you can get a spectrum for each one of these pixels. And the spectrum would reveal, if you're centered on the Earth, interesting things. And this is the whole goal of this. It would detect essentially signs of life in terms of water, oxygen, ozone, CO2, methane. Depending upon how much of each one there is there, you can detect these things in reasonable amounts. So that's that part of the program. Now I'm going to descend into a little bit of techiness, but I think that this